on flash drives, okay, SSDs. And they're starting to approach hard disk drive numbers. They're starting to get really close. There's still the issue of are hard drives more reliable when we get around an electromagnetic field? Has anyone ever taken a computer and had it get erased when you go through the airport? Okay, they're optimized, pretty much optimized now to the very low energy, but back in the 70s, early 80s, you actually had to tell them that you had a computer and they would take it around the X-ray machine so you could put a bomb in it and put it on the other side. No, it's true. They used to do that. Like, you need to go through the scanner so we can make sure you don't have a bomb. And, oh, can we hold your bomb while you go through? And then we'll just put it over here. All right? I'm not saying that security is perfect, but sometimes it's laughable. So it turns out that for backups, and I checked this morning, the numbers still are that you should, if you care about storing data for a really long period of time, you should favor hard disk drives over SSDs. I typically prefer, I use DVDs for long-term storage for some of my consulting business, and then every 10 years I rewrite them, and I haven't lost any data yet. So, and let's face it, blank DVDs are a lot cheaper than a hard drive. Also, I just have to find a DVD reader, not a computer that will support that drive, which can be really, really ugly. So, there's different technologies that the book talks about, SLC, MLC, TLC. I only have these up here for the following joke. Okay? All right. So single level cells, SLCs, say, hey, we can store 1 bit per transistor cell. Yay. Then somebody came along and they said, wait, hold it all. I can now store 2, and it's so amazing. I want people to be so impressed. I'm going to call it multi. And then somebody came along and said, hey, look, here's 3. Oh, crap, we can't call it multi. Someone already took that name. So in flash technology, MLC means 2. TLC, they got smart and they went back to numbering, and they said it's 3. We could go up to quad. Okay, that'd be cool. All right, but we've kind of missed the boat with multi. Although interestingly, this technology was invented. Gosh, what was it? Originally invented in the 50s, but it was too expensive to manufacture. And it wasn't until the end of the 90s that it became cost-effective to manufacture. So the actual inventor of this technology was an engineer in Japan many years ago. He said, hey, we could do this. And then, it was like, okay, and this is how we'll do it. We said, oh, but we can't actually build it. So by now, it turns out that those original ideas, the patents have elapsed. So now people can steal the ideas and make them without paying royalties, which may or may not be a good thing. I don't know. But as we go along, as we said, prices are dropping, technology is improving. This is the number that I said we change, where it says on SSDs it's 0.60. It's currently, I think, somewhere around 0.14, and they expect it to go below 10 cents per gigabyte later this year. This is how the SSDs are laid out, and currently the dominant is flash-based. It uses a particular type of technology called NAND technology. So we have these banks out here, and each one of these flash banks holds so much memory, way bigger than a track. Okay, some of these could be in the megabytes. So if one of them goes bad, then we lose quite a bit. So we work really hard in manufacturing to avoid that. Those lines between the flashes are buses. I want you to notice something, that this is organized around 2 buses. And what that means is that we can have the flash on one of those buses busy at the same time that we can have one of the flashes on the other bus busy. Okay, they're set up that way to get us some parallelism, which is going to get us better performance. Then we have the controller for managing this, because it's got to run its own file system to get good wear leveling. This memory is the equivalent of the memory in the controller. We send stuff to the flash drive with flush, and it says, yep, I've got it. It's not out here in the permanent memory. It's in this volatile memory. And then this guy figures out how to get it here most efficiently. So we don't see this side. Here's our interface. Most SSDs today are either using a pure memory interface, or there's a thing called the Flash I/O interface, and some of them use USB. Has anyone got an actual SSD as opposed to a regular thumb drive? Let's say this is an SSD drive as opposed to a flash drive. If you got one of those, you can plug it on USB. That's like state of the art. But it's so much faster than your USB controller that you're underutilizing the disk. That's why we want to get it closer to the CPU, put it on the motherboard so we can get as fast as possible. Okay. So, some benefits. All right. Because we don't have the rotational and seek delay, reads and writes are faster than traditional disks. Substantially faster. Okay, order of magnitude or more. Because it looks like it's made of real memory, it turns out that the SSDs in terms of performance are getting really, really close to buffer caches. Kind of opens up the whole idea. It's like, well, should we make the buffer cache an SSD? Some very interesting things here. If the buffer cache becomes an SSD, well, SSDs are persistent, and now our buffer cache might become non-volatile. Okay, think about that. Okay, we talked about it. We haven't studied buffer caches in detail, but we talked about how buffer caches work, and that may be the future of how disks work. And your disk, instead of doing disk I/O the way we currently call it might just do paging. Okay? Which would be a really big technology improvement. I don't think that's going to happen personally in my lifetime, and I don't think it's going to happen in your lifetime either, but it could. Okay? I don't think it's going to happen in the next 25 years. SSDs replacing hard drives, I still have a bet that before 2023, the most desktop computers will no longer have a rotational disk. Okay. Unfortunately, I made that bet with somebody who's 10 years older than me, so I might not have to pay off. It turns out that for your drives, remember because of that friction and stuff, remember how in physics I told you friction generates heat? So if you have a rotational disk in your laptop, when you set it down on your lap, and within 5 minutes you go, oh, that's bad. Okay? The flash drives are just silicon. They produce less heat than your CPU. They'll produce about the same amount of heat or slightly more than your memory sticks. And currently, we do open air cooling on those. We don't even push a fan over them. The only fan we've got is for our CPU inside of our laptops. And I got to tell you, this has no fan in it at all. Right? Or if it had, it would be called an iFan. And it would cost, $600. Now, no seeks or rotational delay. We've taken those to zero now. Along the way, too, because of those buses that I was talking about, we can have, to the same device, we can have multiple reads and writes occurring at the same time, which we can't do with a rotational disk. We can only be working on one read or write at a time, okay? And when we're working on them, we call them in flight. So you'll hear about SSDs being able to have more operations in flight, and that just means under execution. We talk about that. You use the term in flight also with CPUs. I've fallen out of that since I haven't been an OS developer in so long. But a lot of OS developers like to talk about that just because in flight sounds much more cooler than concurrently. So it just means concurrent. So we talked about bit fatigue and using wear leveling to deal with that. And the actual technology under the cover, how the blocks work in an SSD, are substantially different than how blocks work in hard disk drives. And that's being worked on. There's tons of changes being worked on all the time. And we're starting to get this all figured out. As I said, the OSTEP authors actually have a lab where they're working on things like this and making them very fast and highly reliable. And they're going to solve it. I think that we're going to solve these two downsides pretty much for good within the next 18 months. And then it's just going to be developing the correct materials so that we can take advantage of that. So that's why I think that in the next 4 years, hard disk drives are going to start to disappear. Okay, so if you have, if you got Maxtor or Seagate stock in your retirement portfolio, you might want to rethink that maneuver. Okay? So next time we're going to talk about file systems. And what I want you guys to do is take a look at the idea about abstractions in the file system, because they're non-trivial. Okay? How many of you knew that there's no such thing on your computer as a file? There's no such thing as a disk. They don't exist. I mean, not a disk. There's no such thing as a directory or a file. They don't exist. They're just, on a hard drive, they're just a collection of sectors, interpreted a particular way. Right? Above that high-level block interface, we see everything as files and directories, and below it, everything is groups of data. And we don't care what the data is. So it turns out this idea of files and directories is completely artificial and provided for you by the operating system, not by anything else. Okay? So that's something to keep in the back of your mind when we talk about file systems. They don't talk in terms of directories or files. They talk about chunks of data. That's all they talk about, blocks. Right? So questions about the magic of hardware? You guys ready to go off and build some hardware? All right, see you guys next time.